Okay, this is the third part of the chapter 4. Let's continue look at the precipitation reaction. So we introduced two kinds of the equation. One is called the molecular equation. Another one is named the ionic equation. Another example is here. So let's take a look at the silver nitrate react with the sodium chloride, and this is a molecular equation. We'll talk about that in the second part. So we can write this molecular equation into ionic form. Yeah, this, for example, this one. We see the AQ. As long as you see AQ after the compound, that means this state symbol tells us this compound is soluble in the water. So if it's soluble, it will form ions, or we say dissociate into ions. This is why we can rewrite this one into this form, ionic form. And similarly, so sodium chloride will be written this one before reaction, and after reaction, this one stay in the solid form, so we cannot separate that one into ions because they will not become ions in water solution. Instead, they will remain in the solid form. We name them precipitate. Yeah. For example, if you precipitate, I showed you some video previously, and this one they can dissociate into ions. So this is after reaction we have this. So we call this one complete ionic equation. This is what we talked about before. And we also introduced the net ionic equation, which means we canceled out some common ions on the both sides, in the reactant side and also the product side. During this reaction, you see this kind of ions before reaction take place. They stay in this form, and after reaction, they still remain in that form. They did not change, they did not do anything. So this is why we call them spectator ions. They just watching. They are just watching, do nothing, contribute nothing. So spectator ions. And the leftover will be net ionic equation, because that really tell you what is essentially what is a real reaction, because that one doesn't really contribute anything. Like I said, you can replace this one by other things, like for example, you replace this one by potassium. At the beginning it's potassium. At the end, they are also potassium ions. They can be cancelled out anyway. So this is why, that ion doesn't really matter. So the really important thing is this ion combined with this ion form this precipitate. So I think we finished talking about the spectator. So what is the procedure for writing the ionic or net ionic equation? Again, I will show you some procedures by text. How to say? You can read through, but you don't have to recite this kind of text. You have to do some practice. So they tell us first we switch the ionic partner. We always use positive ion paired with the negative ions. For example, this one, the lead ions is positive ions. In the chapter 2, when we talk about the namium compound, we said we write the positive on the left and the negative ion on the right. This is default procedure and the way we do it. So this positive will combine with this negative. So that means they switch or they exchange the partner. So this one negative will combine with this positive. Yep. So then we fix a new formula. Yeah. You see, we only have 4, kind of ions. Ions, positive ion, negative ion, positive ion, negative ion. We simply take this positive, combine with this negative, you have this one, right? Yeah. And if we take this positive with this negative, you get this one. Yeah. So, and then we balance the equation and check the solubility to add in the state symbol. Yeah, for example, at the beginning like this, after I do it, I will check the solubility. This one, the lead is an exception for highlight, so it's insoluble. I put a solid here. And this group 1, alkali metal, they're always soluble. So this is why I put the AQ here. So that means we complete the ionic equation by doing that. Then to get the net ionic equation, we remove the spectator. So this is the procedure. Okay, I think like I said in the last week, I will do a lot of in-class practice, including this one. So now I will just go ahead. Yep, we leave the practice to the next class. So for working in solution, there's one very important thing. It's about the concentration. Yeah, the concentration is very important, and there are lots of questions about the concentration calculation. So what is the concentration? It's the amount of the solid present in the certain quantity of the solvents. Do you remember in the first part of this chapter 4, we introduced a lot of terms like solid and solvents, right? Something dissolved in media to form a solution, we call it solid, and the medium, we call it solvents. Okay. So for concentration, there's different definitions, but the first one we will learn today in this Chem111 is molarity. Means the number of moles of the solid dissolved in 1 liter of solution. I think 1 liter is very important. 1 liter, very important. Yeah, it's not other units. Okay, and also this is mole. Okay, anyway, mole over the liter, or the amount of the moles divided by the volume in the units of the liter. That is called a molarity. Sometimes we use a capital M. So the units, according to this equation, will be moles per liter. So the standard notation is M is equals to mole per liter, but during the calculation, I highly recommend you use a mole per liter. It's better than this capital M. The reason is if you use this separate units, you will be able to cancel them out during the calculation. I think it's better. It's obvious during the calculation if you have that one. So let's do the in-class practice. For example, use the previous equation. What is a molarity if we have 0.3 mole of this compound dissolved in this volume of the solution? I think this is a straightforward because the definition of the molarity is equals to the moles divided by liter. So I simply use this one over this one. So the answer will be 1.5. Use this one divided by this one. It's equals to 1.5 mole per liter. As simple as that. Okay. So I will skip this one the next week in class practice because we did it already. So simple. if we continue ask you how many mole of this one are in the 2 liter of this solution, then you can use this molarity times the liter. You will have how many moles. In other words, in order to know how many moles is here, you simply use the molarity times the liter. Yeah, you just convert this equation. So how many moles is equal to the volume times the molarity. So for calculation of this problem solving too, yeah, if we have this gram of this compound dissolved in the water to make this solution, what is the molarity? It's the same. We should use the same equation. The molarity is equals to mole, how many moles, divided by the how many liters. So the only things we need to do is convert this one from the milliliter to liter, and then convert this one from gram to how many moles, right? Okay, we'll do this. Yeah, I recommend you do it by yourself now. Then you compare your answer with mine. I will post the key on the canvas. Also, we will continue this in class practice in the next week. Okay, we stop here. Yeah, thank you.